Form 5 boys and girls, welcome. Today I would like to bring to you a new chapter, the chapter 9, solving triangles. And I would like to say that in this chapter there will be altogether 3 sessions. The first one is called a sine formula, second one is called a cosine formula, and the last one is to use some formulas to find the areas of triangles. And I would like to say that in this chapter, all sessions are in long foundation part. What does it mean? That means that you will only see those questions about this chapter in session B, the long questions only, okay, or in the MC, the last 15 questions. And I would also like to say is that you will not, will be single as a question in session B, okay, because usually we will combine this chapter with chapter 10, the 3-dimensional problem, to ask you together. So you should prepare that this one, okay, the chapter 9 is to learn the basic skill and some formula for you to calculate the length or angles. And actually what you need to do is to understand the chapter 10. That means that you have to understand the 3-dimensional problem, okay, especially 3-dimensional problem, and then you have to use some skill to solve it, and then you apply all the formula you have to learn in chapter 9 to do. Okay, so this is what you need to do. And chapter 9, actually you can see the chapter name is called solving triangles. So what's the meaning of solving triangles? For solving triangles actually means you have to find all the lengths and all the angles within any triangle. So what does it mean any triangle? It means that no matter the triangle is right angle triangle, or even the acute angle triangle or obtuse angle triangle, you need to find. Okay, so before I go to the first session that I want to tell you today, which is a sine formula, I would like to give you some basic notation of this chapter. So first of all, when we talk about any triangle, okay, no matter I'm drawing the acute angle triangle, okay, like this one, acute angle triangle means all angles are less than 90 degrees. So you can see this triangle is an acute angle triangle. So we notice that this triangle as ABC as the 3 vertices. And do remember is that in this chapter, for convenient writing, okay, we have to label, okay, the names of the angles and the lengths, okay, with a certain order. So what does it mean? For example, if I write A, B, and C, the vertices capital A, capital B, capital C this way, then we will say the length, okay, which is opposite to the angle A, will become small a. What does it mean? So you can see what I have highlighted here. So what it means that if I say this angle, okay, at the point capital A, then we will say the length, okay, which is opposite to the angle at A will be called small a. That means that here we will say that small a actually is the length BC. Okay, so this is what the chapters usually write in the way like this, okay, for you to understand the formula. So on the other hand, when we say B and B, C and C, it's just like this. And also you have to understand that for this chapter, because it wants you to well know the formula that you use in solving the triangle. So you can see the board would omit writing the angle symbol. For example, you will simply write A, capital A, to represent the angle BAC. But do remember, this writing is just for you to learn in this chapter, but it cannot be used in DSE, because in DSE you should always write in the suitable symbol to represent an angle. For example, if I want to highlight this one, this angle should be angle BAC or angle CAB. Don't just write angle A as mentioned in junior form, because angle A may sometimes confusing with another angles. So always remember to use 3 letters name. Okay, so do remember this one is a very standard form to write 3 letters name. Use 3 letters to represent an angle. 3 letters name. Okay, so remember this important thing here. Okay, so now before we really want to investigate what's your sine formula, so there will be also some knowledge you need to remember first. So first of all, you can see in chapter 9.0 review, it gives you the things you learned in Form 2, especially for right angle triangle. So I want to highlight again that the things you learned in Form 2 is focusing about the right angle triangle. That means that there is a 90 degrees in your triangle, including Pythagoras theorem and also the sine, cosine, tangent ratio. So you should not be very strange about this one, because you just reviewed this one last year when we learned the CST. okay, the CST, more about trigonometry, in the chapter 4, in Form 4 chapter 12, the last chapter. Okay, you should remember this. Besides of this, so you have to remember that, okay, in chapter 12 of your Form 4 solving, the more about trigonometry, we also focus about how to solve the equation with finding the angles. What does it mean? For example, if I say something like this, for example, we say sine, for example, I say, oh, I cannot write anything here, so let me say again, yeah. For example, when we say sine theta equals to 1/2, then you should understand what you have learned in last year. We will say that when we want to find this angle, you could not just write 30 degrees as you can see in calculator, but there will be also some angle which is not 30 degrees, which is not in the same quadrant as the 30 degree. For example, I can take the second quadrant one, which is the second quadrant, okay, which is 150, to represent sine theta is 1/2. It is because that if I take a look on this table, we will say that if I say this one is 30 degree, it means that the 30 degrees is a reference angle. Then you have to find another angle which have the same 30 degrees as a reference angle here. So we will take this one, which you can represent by using 180 minus 30. So you have 150 here. So these are the things you learned, okay, in last year when we talk about the CST. So we will use this also, okay, in this chapter, because we have to deal with sine, cosine, tangent in this chapter. Okay, so this is what you need to remember. And also, you have to understand, because now we are working on triangle, not only right angle triangle, but any triangles. It means that this time we will also have to remember the things you learned in Form 1, which is the congruent triangle. So why do we have to learn this one? Because when we say now, when we go back to the original problem, is that now, if I have a triangle, okay, so you should know that in a triangle there should be 3 lengths and 3 angles together. That means that altogether in a triangle there should be 6 information altogether. That means that there should be 6 things that you can find inside a triangle, including 3 sizes and also 3 angles. But you may ask, okay, Mr. Wong, okay, how can we determine whether we can really be able to find, okay, we are able to find the lengths and the angles in triangle? So the most important thing is that if we can really find all the things, okay, the triangle should be fixed. So what I mean of fixed, that means that the lengths and the angle would not be changed according to the information given. So the next question is that you may ask yourself, how many information should be given in the triangle in order to fix the other? Okay, that means that if I have only one length of a triangle, can we say all the angles should be fixed? For example, just give an example like this. For example, now I draw here. For example, now I say now if I have a triangle, if I just know this one is 6 cm, can I really say this angle is fixed, this angle is fixed, this angle is fixed? So surely this one is not. Why? Because you can just imagine that, okay, the triangle can be drawn in this way, because we just fixed the 6 cm here, so you can also draw another triangle like in this way. Then you can easily to see that these 2 triangles have different measure, no matter in length and angles. So this is a problem, is that how many things that we can fix, okay, the triangle. So the answer is very simple. So we just recall what we learned in congruent triangle. So if you still remember, the congruent triangle means, okay, the 2 triangles are identically the same. All the lengths and angles are the same with correspondence. What's the mean correspondence? For example, if I say 1 on the left, so you have the same shape and the same size on the right, so you have the length to length, okay, which called the corresponding, okay, corresponding lengths or corresponding size or corresponding angles. So you will see this way in congruent triangles here. And also, you should still remember that when we talk about the congruent triangles, you should have 3 information, because when we talk about, okay, we should have 3 information. So why? Because if you talk about the reasons to say the 2 triangles are congruent, you have the following, which is the SAS, SSS, ASA, AAS, and the last one is the RHS. So you can see each of the reasons here should have 3 pairs of information when we talk about the 2 triangles. That means that when we have known the 3 information within a triangle, then the triangle should be fixed with all the lengths, all the angles. Because if you have another one, it should be congruent to the original one. That means that it's fixed in length and angle. So we will say you have 3 to find the other 3. So this is also the idea that you need to keep in mind, okay, when you learn this chapter. Because in this chapter, you should always be able to find 3 information given from the question in order to let you find the other thing. Okay, that means that you should use 3 information always when you write any step to solve the problem. Okay, so this is one more thing that you need to review before you learn the sine formula. So if no problem about this, then we will go to really the formula. So do remember is that these 3 sections, okay, are talking about 3 or 4 different formulas. And actually the formulas are very easy to remember, just like what you learn in physics, okay, just a very easy formula. Then what you need to do is just you apply it frequently when you solve the problem. But in maths here, okay, when we talk about sine formula, cosine formula, or even area of triangle, there will be some points you need to take note, okay? So I will explain to you through the clips. But the most important thing is that the first one, sine formula, is a very easy formula. What does it mean? For sine formula, would be the formula like this, which is this one. So you can see the formula is A over sine A equals to B over sine B equals to C over sine C. So I will prove this one now. But before I prove this one, I would like to say is that the use of this one is actually to take any 2 pairs to compare as an equation. That means that practically we will have to take, for example, you take the A over sine A equals to B over sine B, or even you can take A over sine A equals to C over sine C, because the A, B, C order is just defined by you. That means that if you take this one A, this one B, this one C, it's okay. So even you can change this one is B, this one is A, this one is C also. Just up to you. That means that the lattice order is not important in this formula. What you need to remember is that you need to take 2 pairs of fractions, 2 pairs, okay, which is the length and the sine angle pair as a fraction to compare the other, okay? And how, you may ask, oh, how this formula works or how this formula used, okay, practically. So we will say that in order to know why we have this such a formula, so we have to know how to prove. So in order to prove this one, so you can see the book would use some way to prove, but I don't think that is a very good proof. Actually, the standard proof, okay, will be shown in your book, chapter 9, page 48. Although the book says it is an alternate proof, actually it is not alternate proof. It is actually the standard way to prove, okay, the sine formula using the concept that you learned in Form 3, which is called the circumcenter of triangle. So I don't know whether you still remember what's the meaning of circumcenter. Circumcenter is actually the perpendicular bisectors of each of the sides of the triangles that you intersect. Then you will have the point here, so we call it circumcenter. And also, if you still remember circumcenter, we have also a very important thing, is that the circumcenter actually is the circle, okay, the circumscribed circle, okay, of the triangle, the center. It means that when we have a triangle, okay, so I just draw again here, for example, you have a triangle. Okay, so if you still remember what you learned about circle, no matter in Form 4 and Form 5, we will say that for every triangle, there should be a circle that can pass through all the vertices. Sorry, I should draw one much better. For example, we will say that we can always draw a circle, okay, passes through all the vertices, okay, all the vertices of this triangle. For example, here, 1, 2, and 3. So we will call this circle is called a circumcircle. Okay, it's just a circle, just round about the triangle here, so we call it circumcircle. And we will say the center of this circle is called a circumcenter. And actually, the proof of this one is very, very easy, because now when we talk about this triangle, for example, you can see there's a black triangle inside, which is here. So I do not mark all the labels, so I just mark one of the labels. For example, now I just say this one is called A. So you have the corresponding length A here. Then now, how do we interpret, okay, the sine formula works? Actually, you can see it now. When we draw the circle with the pairs of length and angles like this, then now I do a thing is that you can see A now is your target. Then there should be another point, such as B and C. Okay, there will be 2 points. So what we need to do is that now I take another point of the triangle. For example, this time I take the point B. And then what we do is that we join the B and O. O, we say the circumcenter of the triangle by the diameter. That means that you draw this purple line diameter. Then you have another point here. For example, I say this point is called D. Okay, it's called D. And this one is a triangle vertex we call C here. So you can see that now we form a triangle BCD. And do be careful that because you understand that BD is the diameter of the circumcircle. It means that the angle BCD should be 90 degrees because of angle in semicircle. Angle in semicircle. So you know that it is 90. So you can have something comes. Why? Because you can easily see it, okay, once you have this right angle triangle. And also you can notice that if I say this angle, okay, so this angle is A, okay, as we say, okay, in this chapter we use the capital A only to represent this angle. But the most important thing is that within this circle, you can easily see this angle A should be the same as angle C dot bar. The reason is simply by angles in same segment. Okay, because by angle in same segment, you will see these two angles are the same. So what does it mean? That means that now we can bring the relation, okay, we can bring the relation to see, okay, within this triangle BCD and also this angle. So how do we form the formula? So we can say now the formula that we can form will be like in this way. For example, here in this triangle, I can write sine angle B dot C, which is the angle we are talking about, should be the opposite side, which is A over the D. And here you can see D stand for the diameter of the circle. But you know that sine angle BDC just the same as sine A, as we mentioned. So you have this. Then if you rearrange the terms, okay, sorry, it should not be A here. I skipped the step. So actually it's not A. Sorry, I had to write again. Yep. So this one should be A over D. Okay, because of opposite side over hypotenuse using a typical sine ratio. Then you can see now after we arrange it, we can write D equals to A over sine capital A. But you know that D is what? D is the diameter of the circumcircle. It means that this one is a fixed value. Because you understand that once you have the triangle, you have a fixed circle that can run, okay, that can run about the triangle. So we call it circumcircle. So we will say the diameter of the circle should be fixed. That means that A over sine A is fixed to be diameter. So on the other hand, if I want to talk about the other length, for example, this time if I take, okay, for example, I say this one is B, and then you have the angle B here. Oh, sorry, not this is not B, it should be C. Okay, because we're using the same notation as the symbol required here. So this one should not be B. For example, we say this time, if I say this length is C. Okay, so you can use the same way to get the results because you can actually use the same technique. Is that I take another one, for example, I say take the A and then you cross like this, then you can form another right angle triangle. Okay, with also we say at this length, for example, this one, the length I'm just showing here is also D because it just also pass through the center of the circle. So you can actually now you have another right angle triangle like this, and still you would get the answer because this angle and this would be also the angle in same segment. So we will say that, for example, no matter you take the angle A and the sine A, or even you take the angle B and the sine B, and also you take the angle C and the sine C, all the fractions about the length and the side of the angle should becomes the diameter of the circle. So it works. Okay, so do remember is that this one is a very, very important, okay, formula that you need to learn. This is called the sine formula, and also it relates to what? Relates to circle of the triangle. So this is also very important for you to do some of the MC questions, especially if I want to know the circle of this triangle. Okay, so you may also ask, oh, Mr. Wong, okay, you draw the triangle so nice, you draw an acute angle triangle. How about if the triangle is not acute? For example, it is obtuse angle triangle. So I've also prepared the another picture for you, so you can see this time I draw the obtuse angle triangle, this one A, B, and C like this. But you have to understand is that now if I say the angle BAC, or we simply say the angle A is obtuse over 90 degrees, then you should understand that the circumcenter should lie outside the triangle. It is because simply that if the angle BAC is obtuse, then the angle at center should be over 180. It should be reverse angle. It means that the center should outside the triangle in order to make the arc, which is over half circle. So you should understand the center outside. So you can also construct a similar thing is that for this one, if I want to prove A over sine A is the diameter, so this time I use the point B again to pass through the center to form a diameter. Then this time this triangle would be the triangle you can construct. But this time you have to understand that the angle B, for example, B dot A here, B dot C should not be equal to BAC. Originally, in the acute angle form, they're the same because by angle in same segment. But if the circumcenter is outside the triangle, you cannot form the angle in same segment. But you can use the cyclic quadrilateral, AB dot C here, cyclic quadrilateral, to say the angle B dot C should be 180 subtract the original one because of opposite angles of cyclic quadrilateral. So here, even you have 180 degrees minus theta, you can still form the sine ratio, which is sine 180 degrees minus theta equals to, once again, A over D in this triangle BCD. In the triangle BCD, you can also form a sine ratio this. But you understand in form 4 chapter 12, we say sine 180 degrees minus theta would eventually becomes positive sine theta because 180 degrees minus theta is somewhere else in quadrant 2. So the sine is positive. So you can see that the sine, positive and negative side preserved, even you have 180 degrees minus theta. So you can see the formula still works because you can see sine theta is A over D, it's the same here. That means that for actually the sine formula, you can use it for any triangles, no matter the triangle is acute angled or some obtuse angle inside the triangle, you can still use it. So this is the idea. Now we go to the practical use of this one. Before we talk about the practical use here, so you can see the book show you the notes. The first one is said by the sine formula, the length ratio is proportional to the sine ratio. So this is what I just said. But do remember is that the ratio should have sine. That means that you cannot just say, oh, Mr. Wong, I use the length over the angle. No, but we have to use length over sine of its corresponding angle. Length over sine is corresponding angle. Then you have the proportion relation. You have the proportion relation just stated in the book. But I would also like to say is that in using the sine formula, there will be also two important notes you need to remember. The second one, it says, in a triangle, the largest angle is opposite to the longer side. And vice versa, we have smallest angle opposite the shorter side. So this statement actually refers to one geometrical property about a triangle is called the greater angle longer side. What does it mean? That means that for every triangle, the greater length should corresponding to the larger angle within the triangle. Even the shape is you cannot predict, but we can always sure that the longer length should opposite to the larger angle. So this one can be proved by using geometry, as it is proved many years ago by Euclid. But I'm not spending time to talk about here. And the last point, is referring to the part B, this point, the greatest angle longer side. It's talking about that when we use the formula, actually you can find the formula by two ways. First of all, you can find length or angles because you can easily see in a triangle, either you have to find length or the size or the angles. Now, we will say that in order to use it to find angles, then you will say they will have two values. One is two values because you have to understand that in using this formula, okay, you have to take two ways, two fashions. Then you will see that when you find angle, you may deal with sine. Okay, that means that eventually you may have something like sine theta. Okay, you may have something like sine theta. Okay, equals to something. But you have to understand is that when we say sine theta equals something, you want to find that angle. You can have two values. As you still remember when we solved the equation with angles, then you can have angles in quadrant 1 or in quadrant 2. Just like when I say here, if I say one angle is alpha, then you may have 100 degrees minus alpha as the quadrant 2 angle. So this one, okay, will be combined with B to talk to you today. Okay, so just keep in mind first. And now we have to go to some easy example to let you see how do we use the formula. So when we say here, you can see there's a triangle here, ABC, and I give you two angles and one length, which is B, equals to 5 cm. Then you can actually know the answer already because now you have free information. Then we'll try to see whether you can apply this formula. So we'll say in order to apply this formula, first of all, you have to take, okay, you have to take what? You have to take two pairs of sides and angle correspondingly. What does it mean? For example, if I say now I take B as a sine, it refers to the corresponding angle 46, which is opposite to it. That means that in other words, if I want to find A, so what we need to do is that we have to take the angle opposite to it, which is 50 degrees. Then after this, then you can actually now to form the formula. Do remember is that practically, okay, that means that in DSC, you don't need to write those words here. That means that you can actually start from your word. For example, B over sine 46 would be one of the pair. So I can write B over sine 46. And actually, the unit cm, you don't need to write in the step also. That means that you can just write 5 over sine 46 here. And then the next is that for the length A and corresponding angle side, the 50 degrees, you can also write in pairs to write A over sine 50. Okay? That means that what you need to do is just use length over sine angle equals to length over sine angle. Okay? This is the sine formula. Then what you need to do is just use your calculator to calculate. So you can see the after that, then you will have this one. And once again, after this, then you cannot just find the value by reading sine 50 degrees because we don't know, and also sine 46. So what you need to do is you use a calculator and give correct to three significant figures if necessary, if required. Okay, so you just write the answer like this. So very easy, actually. So before we go to the last thing about the sine formula, you need to remember. So you can easily see that now, because for the sine formula, we should take two pairs of sine angles to compare. That means that there will be only three cases that the sine formula can help you find the triangle, which is the cases of AAS, ASA, and also this one is not a formal case in congruent triangle, but sometimes we may have to use it. It's called the SSA. Okay, but you have to know that this one is not congruent. So because this one is not congruent, it means that there will be something you need to remember. Okay, but anyway, so for the congruent two, which is the AAS and ASA, so why we can surely know that we can use sine formula to solve, because you understand that in this scenario, okay, both scenario gives you 2A, okay, for example AAS or ASA. But actually, you know that once we have known any two angles in a triangle, you should know the third one, because the third angle here, simply you can use angle sum of triangle to find. That means that when we use the sine formula, we have two angles known, so you should have got all the angles known. Because you have all the angles known, so once you have known one more length of the side, then you can use that angle and the side to have becomes the pair, and then you can take out any side to pair with the known angle because all the angles known. So you can easily see why we can use sine formula to solve these two problems, because you have known all the angles. Once you know one of the side, you can use any angle to compare with the side to find that side. So very easy, okay? But there would be the case that we have to consider. It would be the second one, which is that this time we are not known all the angles. That means that we are not finding angles, but we have to find sorry, I should not say we are not finding the side, because once we have known the angles, okay, we can find the side. But this time I give you all the sides known. For example, I give you the A and C known. Okay, I don't give you the B, but I give you A and C. But this time I just give you one angle. So you may ask, okay, what we may not know the angle corresponding. This is because now we go to break. That means that is SSA. So why we have such an SSA here? So I can give you the before I go to the figure, I just give you the example like this. Okay, let me see here. Yeah. So I just go directly to see. Okay, why you have such a result here? For example, now before I go to the page talking about this, so we take a look at example 3 first. For example, this time you can see that you have the scenario like this. Okay, which you have the triangle. So I just draw randomly, but because I don't know what is the shape of triangle, so I just draw randomly. For example, here. For example, now I know that the angle is 60 degrees. And B, which is opposite to B here, is 4 cm. And then also we say the A, which is corresponding to here, is 2 square 3 cm. Now you have to solve the triangle. So in order to solve this triangle, first of all, you may have to find this angle. Okay, then you can actually now use the sine formula to solve. For example, this time I should say B, which is 4 over sine B, will becomes equals to 2 to the 3 over sine 60. Okay, but this time when you simplify your result, you will see there is a thing here. You will see that eventually you have sine B here, and you can see this time after you've got sine B, you got 1. So this is not difficult to at all, because actually after you have got sine B equals to 1, so what we need to do is just you press your calculator by pressing shift sine, then you can find back the angle. For example, here you should have 90. That means that here you will understand that it's 90 degrees. That means that the triangle should actually drawn in this way. I'm drawing wrong here. Okay, so actually the triangle should be something like this. Okay, for example like this, we will say this one 90 degrees and this one 60. And also with this one is 4, this one is 2 square 3 with the label A, B, and C. Okay, so it should be something like this. Okay, so this is not difficult, even you think about finding the angle. But now I would like to give you another example that you will understand what is going on. For example, here you can see now I give you this 60, 4, and 2. So this time if I have 60, 4, and 2, this time you will see that once again we have to work the formula to write 4 over sine B in part B equals to 2 over sine 60. But this time you can see that now what you have for sine B will become to be square root of 3. But you know that square root of 3 is over 1. So this one will make you undefined, because you cannot have sine B equals to square root of 3. So this one will give you undefined. Or in the calculator will show you the math error. So because there is an error, okay, in your work, okay, so in your work, that means that actually it gives you the problem. So what is the problem here? So now I would like you to take a look to see what the book gives you in the figure. So actually this figure shows you that the possibilities of when we talk about the SSA, that means that if I give you two sides and angle. So you understand that when we have known the two sizes and the opposite angles. For example, if I say now I know that this one, as the book say here, for example, I say this one is length C, and then I have the B here, so it will be something like this. Okay, so we assume that this angle is less than 90. So later I will tell about this one more than 90 here. So you can easily see that in order to say the length A, the A, okay, the length A here should correspond to what? Should correspond to the angles, okay, you want to have, okay, to correspond here. For example, if I say now the angle B, for example, because opposite B, for example, if I want to have this one, for example, I say 60 degrees, it means that now we have to draw, okay, a line here to make this one equal to 60. Okay, but okay, actually you will know that it may not be 60 here, so you may have to adjust. So when you adjust, that means that you may adjust the length something like B here in order to let you fit actually here is 60 degrees. Okay, so this is what you can do. But you have to understand the most important thing is that sometimes you will have more than one triangle. So sometimes you will have more than one triangle. So what does it mean? So it means that now, if I want to say once again, is that now, if I say this one is B, and now, for example, I want to fix this angle. For example, this one is fixed, okay, as unchanged. But now, if I say about the length A, okay, so you can understand is that the A cannot be too long or too short. Or actually, it can be very, very long, but it cannot be too short. For example, can we say that A is just only short like this? It's not possible. Because if A is as short in this way, even, okay, you draw, okay, the A to where you cannot reach the bottom line. It means that the A should have some restriction here. So you can see those restriction, okay, within this figure. But the most important thing is that I would like you to focus on the third one, okay? Actually, for these four cases, the first one, the second one, and the fourth one can be easily seen using the formula. But the third one, okay, this one you usually ignore. But do remember is that this third one actually just tells you a very important thing is that now, because, okay, you fix the angle A only and also the length, that means that you may have different what? You have different, okay, angle B, okay, different angle B. If I alter the length A to the other side, that means that this one would give you a very important thing is that it gives you two solutions or two values, but all the other would give you one value or no value. Okay, so if you do not understand this figure throughout, it's okay, because practically you don't need to use. But the most important thing is that now we go to see really some examples. For example, now I skip example 4 because it's just quite easy, or even this figure, okay, I just skip it, and then we go to the practical problem. Now, for example, now I want to say this one in example 6. So in example 6, actually this one is to find length, so there's no problem. So even this one is not in triangle, but don't worry because you can always construct the figure by adding the lines. For example here, okay, I should draw it better. Sorry, I should draw it better. For example here, go back here. Let me see. Yeah, for example in this question, example 6 here. So now I can draw, okay, a line here which is parallel to A dot. And for example, I say this one is E. Then you can easily see that after you draw this, then you can have a triangle here. Okay, you have a triangle here. And also this parallel will give you, no, this one is also 130 degrees by corresponding angles. So you can see now you have the triangle AS, triangle with AS form. Then actually you can find all the things, all the lengths here. Why? Because you can see this 130 degrees corresponding to XCM. That means that if you want to find AD, just like the EC in this figure, you pair up with 20 degrees. Okay, so this is part A. Or even when you find a DC is also easy because you want to find DC just like you find AE. But before you find AE, you understand that the AE is simply what? Is simply 9 subtract what? Is AB subtract EB. Then we go back to this triangle and then to pair up again. So you can see to find length is just easy because what you need to do is you apply sine formula and then you word the answer directly. No big problem. But when we talk about the there is no angle case here. Yeah. So if I talk about the angle case, we go back to here. So I think that I should give you the angle case. For example, this time I would like you to take a look on example 5. So for example 5, this time, okay, you may have to draw the figure by yourself, but even you don't draw the figure by yourself, you can just use the formula directly. For example, this time I just go to the formula directly by writing A over sine A, which is sine 150 on the denominator and 10 as the numerator, and then over 6 over sine B. But this time you can see a very important thing is that this time you will get the sine B here is about what? So this one you can check using your calculator that this one would give you this, which is 0.3 here. So you have to understand is that now, if we have now, so if this time you have, here. Yeah, so if this time you have sine B, let me see. Yeah, if sine b equals to 0.3 here, so once you check by using the calculator, okay, you will see that b will have the two angles. For example, this one you will have the first is about 70.5 degrees, but you understand is that because as we say that should be the second quadrant angle, so you may also say, oh Mr. Wong, do I need to I may have this one. But do remember is that we will not write all the angles. Why? Because you understand a very important thing that this angle, okay, this one, 180 degrees minus 70.5 degrees, okay, this one, you will see that this one is what? This one is about 162.5 degrees. But you understand a very important thing is that in this question, the part A, okay, when you compare the length of A and B, so you can see at this time the A, okay, is greater than B. So you should sure that the angle A should also be greater than angle B. But you can see at this time, if I give the second quadrant angle, which is the angle B, which is over the 150, that means that this time you have to reject this answer. That means that if practically, if you write this one, okay, in your work, you need to reject. The reason is because greater angle, okay, longer side. That means that now you know that A is the longest. So angle B should not be, okay, A is greater. So B cannot be, this angle cannot be greater than A. So you have to reject this one and then just keep the angle here, which is this. But when you see the part B here, you can also see the book. We'll show you the example like this, the part B. But this time the part B, you can see also you have two angles. But, okay, but this time you can see there is a problem. The problem is that after you have got the B, is 48.59 degrees. But you can see this angle will be contradicted to what? To contradict to 150, because you can see when you add these two angles here, you will become over 180 here. That means that you have no solution. So it is not surprising that you will see this one has no solution eventually, because after you have found B, even you don't check here, you have to find the angle C. But you should use the angle side triangle to find angle C, so you can see here. Okay, you can see using angle side triangle to find the angle C. So it's not a problem that you haven't checked in this step, but you can check in angle side triangle. Then you can also see there's a problem here. So I think that sine formula, that will be also some of the things that you will find during you do the practice. Okay, but I think that okay, today I will not make the clip too long. Okay, so let me see if I need to give you another clip to talk about the sine formula later. But before, okay, I end the clip, so I would like to assign you to do something, okay, in order to let us, okay, be more confident to discuss, okay. So the classwork will be this 8 question. Try to do these 8 questions as a practice, and let me check with you later. Thank you and goodbye.